this one is a N-type silicon. This is the P-type silicon. So it's like diode. This is P. This is N. P-N diode. Now, silicon solar cell consists of a thin slice of P-type crystal silicon into which a very thin layer of N-type silicon material is diffused. So this is the sunlight. The solar cell, and this one is the PN junction. PN junction. The solar cell works on the principle of the photovoltaic effect, which is a process of generating an EMF as a result of absorption of ionizing radiation. But we know that in N-type silicon, the majority carrier is electron. Electron is the majority carrier, and in P-type silicon, the holes are majority carriers. Now, when the two pieces of the silicon containing the N-type and P-type impurities are connected by some means, a PN junction is created. So this is the PN junction. At the instant of the PN junction formation, the free electron from the N region begin to diffuse. Free electron from the N region begin to diffuse across the junction into the P region, where they combine with holes. Near the junction. In that way, the N region loses free electron as they diffuse in the junction. This creates a layer of positive charges near the junction. That is, in the junction there is a layer of positive ions. Similarly, as the electron moves the junction, in the P region loses holes. As the electron moves in the junctions, in the P region loses holes as the electron holes combine. The result is that there is a layer of negative charges. Layer of negative charges near the junction. These two layers of positive and negative charges form the depletion region or the depletion layer. So this one is the depletion region or depletion layer. The term depletion is due to the fact that means the the term depletion is due to the fact that near the junction the region is depleted, that is emptied of charge carrier, that is free electrons and holes, due to the diffusion across the junction. That is, this portion there is no charge, this charge free region. It may be noted that the depletion layer is formed by very quickly and it is very thin compared to the N region and P region. Once the P-N junction is formed, the depletion region layer created, the diffusion of electrons stops. That's once the depletion region is created, the diffusion is stopped. On the other word, the depletion region acts as a barrier to the further movement of the free electron across the junction. The positive and the negative charges set up an electric field. The positive and negative charges set up an electric field E. electric field E. The electric field is a barrier to the free electron in the n region. There exists a potential difference across the depletion layer and is called the barrier potential. And this one is called barrier potential. It is denoted as V0. The barrier potential of a p-n junction depends upon the several factors, including the type of the semiconductor material, the amount of doping and the temperature. A typical barrier voltage or the potential is approximately for silicon it is 0.7 volt. For germanium it is 0.3 volt.